This unit is on analyzing data or analyzing information, which is one of the main components of statistics, along with collecting information and drawing conclusions or inferences of it. So with this one, I just want to start with a little vocabulary that you should be familiar with, as well as how some statistics can be done badly, or can be done to sort of, you can twist things to your point of view if you want to have a certain point of view. So in statistics, we deal with individuals and variables, and individuals are, well, people. Could also be animals. Or objects. So we want to know the most popular social media platform. So we talk to people. We want to know the average lifespan of a certain animal. So we study animals and measure their lifespans. We want to study the certain dimensions of certain objects. So we study objects. And within those, people, animals, objects, have certain characteristics. And we call those variables. So variables can be broken down into quantitative or categorical. So quantitative, quantity, is data that is numerical, or it has some kind of inherent order. So what could you measure? People, animals, objects. That's a quantity. You want to know something about people, you could measure their... Really? Nothing? What do you want to know? Height. Because those are numbers, and they have an inherent order. What else?
Weight.
Weight. Sorry?
Age.
Age, yes. For adults, you may want to measure their income. All of these are numerical quantities. Weight is another numerical quantity. Number of years of education is another numerical quantity. Okay? On the other hand, categorical data, the data is grouped into categories which often doesn't have an inherent order. Or another way to think about it, like quantitative data, we could find like the average of. So if you measure a bunch of people's height, you can find the average. If you determine a number of people's age, you can determine the average. Same with income, things like that. This type of data are things that you can't average, okay? But it's information about individuals. So say something like, if we're talking about people, their address. Okay, it's information about people, it's data. Okay, but it doesn't really have an inherent order. Like you can't list addresses from smallest to largest. That doesn't make any sense. Okay. A person's ethnicity. Notice like these are not numbers. They may contain some numbers, But we can't do things like find the average. Like an address will contain numbers, but you can't find an average address. Okay? So another one along that line would be something like postal code. Yes, they contain numbers, but you can't find an average postal code. You can't really list postal codes from smallest to largest. I mean, I suppose you could do alphabetical. And type of job that they have, their relationship status, single, married, divorced, what have you. So just as a little practice, we've got some information here, we've got some data. And we are asked to list the variables as well as what specific kind of variable it is. First of all, who are the individuals in this data set? Yeah, the student names, the students. So, I mean, I know I didn't ask you this, but in this case, the individuals are the students. And it looks like we have quantitative variables as well as some categorical variables. Which ones would you say are quantitative? Height, exam score, yeah. Therefore, the categorical ones would be dominant hand, because it's only one and two left or right, and postal code. And what we're going to do later in this unit is we're going to study categorical variables specifically, like how we analyze them, how we can graph them and analyze them from there, and then the same with quantitative, certain measures that we can use. Okay. Okay. I just want you to look at these two graphs. Here's how you can use data, or here's how you can use statistics to be misleading. Okay. So the first graph is what we call a pictograph, because the information is in the form of pictures. Okay. And we're talking about Kobe Bryant, and the graph is titled Kobe was the ball hog. And it lists the number of made shots as well as the number of assists. Okay. And this is average per game in a certain season. How many made shots did he have on average? 10, because that's how high that basketball reaches. What about assists? 5. Okay. So would you all agree that the number of made shots is twice the assists? Do the basketballs look like that? No. It looks like I could fit like 4 of these in here. So it's misleading because the pictograph makes it look like, oh, well, he had like way more made shots than assists, 4 times as much. Whereas you guys were able to read it correctly. In reality, it's only 2 times as much. So that's sort of the disadvantage of pictographs, is things can be made to look a lot more different than they are in reality. Okay. So for this one, the made shots, 10. twice the assists. Five. But the basketballs make it look like it's 4 times as much. Or 4 times as big. That makes it misleading. Okay? It's the width. Like you guys were able to read the actual correct data values by looking at the heights of the basketballs, but it's the widths that makes it deceiving. Okay? And that's a lot. Pictographs do that a lot. So what would be better, and we're going to look at this, is a bar graph. So a bar graph, I'll do one very simple one. So this is made shots. As far as assists, that's more accurate because the width of the bars are the same. So you just have to focus on the heights. And this bar is actually twice the size of this bar. The second graph dependable trucks. The percent of trucks by brand for the last 10 years that are still on the road. Okay. What do you notice? Chevy is seems to be the best. This is Nissan down here, by the way. I know that's hard to read. Compare Chevy and Nissan. Sorry? Yeah, big difference between the two. I mean, like if you look at this, it looks like Chevy is, I don't know how many bars of these could you fit in here? 1, 2, 3, 4, 5, 6, 7. So it looks like it's 7 times better. But look at the percentages. It starts at 95, right? So this is a little higher than 98%. This is a little higher than 95%. That's not 7 times as big. Okay. So the issue with this graph is the y-axis. It should start as 0 to get a good comparison. Because if you made a bar graph, where we had, so let's see, we got 100, and then let's do 90, 80, 70, 60, 50, 40, oops. 30, 20, 10, 0. Chevy would look like that. Okay. Ford would be between 97 and 98. So Ford would be a little lower. Toyota would be a little lower than that. And then finally, these just above 95. It's close enough for now. So if you look at that, that's what it really should look like. And then you can see that, yeah, Chevy is the best, but it's not a huge difference between the four brands of trucks. Okay. So deception is the y-axis doesn't start at 0. And just as one example, it makes it look like Chevy is way more dependable, way better than Misleading. In reality, it's not. So these are a couple of things that you want to keep an eye on when you're looking at graphs. Okay. Is there any way the graph could be deceiving the way it is presented? And these are a couple of common ones. So here, just as sort of a general things to look for, it may not have axis labels or scales. In which case it's kind of hard to tell if it's accurate or not. Okay? It may cut off the x-axis or y-axis. Starting a weird place, like this one started at 95 and went to 100. And instead of a bar graph, it may use pictures. In other words, a pictograph. And a pictograph is generally not good. So we really don't look at pictographs too much. We're going to look at bar graphs, and then we're going to look at other types of graphs as well. Okay. So just to see, I'm not going to write any notes on this next part. Most of the lessons have what's called discussion at the end of them. And you can look at my written notes on these in Teams. And sometimes I won't even go to the discussion. I'll just say, you know, if you want to look at the discussion for some further information, you can go to Teams. Okay. So here we have a couple of graphs. First, Planned Parenthood Federation of America, which deals with abortions. So abortions up, life-saving procedures down. And this is from 2006 to 2013. And they're showing a graph, it's actually 2 lines, where the first represents the number of cancer screening and prevention services, and clearly it's gone down over this number of years, from just over 2 million to looks like over 900,000. The abortions, 280, I'm not sure what that says, but then it goes up to about 327. What's wrong with that?
They're not related.
What do you mean?
Like, cancer screening and abortion.
Well, they could be related, but look at the numbers. What's that? Yeah, it doesn't have a scale. Because if you look at, I mean, how much do the abortions increase? Let's assume this is 280. About 40 to 50,000, right? How much do the cancer screenings decrease? Over 1 million. Yet the arrows look about the same. So it's giving the impression that there's been way few, in reality, there's way fewer cancer screening and prevention services. And yes, there are more abortions, but not in relation to this. Okay. So that's what would be wrong with that graph. is not using a scale. And finally, this last one, gas prices. And again, looks like we're in the threes. So I think that's 340. And then this bottom one would be, trying to see what it goes up by. Yeah, because it looks like it's going up and down by 0.05. And so this one should probably be obvious to you. What's wrong with it? Doesn't start at 0. So it's making it look like, yeah, this is a gradual decline, but then this is a little bit sharper. But if we started it at 0, okay, I mean, it would probably look something like, not even that, like that, almost flat, if we started it at 0. Okay,